Okay, I'm gonna give you all your answers to your 3.5 homework, both of them, and then probably all of the answers to the quiz, so you'll want to have that. I don't know if you have them back or if Mrs. Richin still has them. I'll have them graded hopefully later today. Sorry I didn't get this video up over the weekend. Had visitors all day Saturday, and then yesterday he was in a new room, so there was really nowhere to do it in his new room, and then I was just going to do it anyway later that afternoon, and then we had to move rooms again, and by the time we moved rooms again it just got late, and I was like, well, screw it, it's already too late. I don't expect them to watch it at this time. So here it is, all 3.5. Basically the two most important things in 3.5 are just knowing what the derivative of cosine and sine are. Oops, there shouldn't be an equal sign right there. Bad. And this pen is dead. So you better remember, derivative of cosine is negative sine, and the derivative of sine is cosine. That'll come up throughout all of these problems pretty much. So number one is just finding, let's see, what is number one? I'm looking at number 18. I'm not ready for that yet. I think number one is just derivative. Yeah, just doing some derivatives. 1 plus x minus the cosine of x. So when you're doing these derivatives, it's just like you're doing a polynomial. You just do the derivative of each one. So derivative of 1 is nothing. Derivative of x is 1. Derivative of negative cosine of x. Well, derivative of cosine is negative sine. So if you have negative cosine, you're going to have minus, and the derivative of cosine would be negative sine. So you'd have minus negative, so it's going to be 1 plus the sine of x. That's your answer. I think this pen is dead too. Okay, 3, same thing, just doing derivatives. 1 over x plus 5 sine of x. Same thing, just do each one individually. So when you do the derivative of 1 over x, easiest just to change it to x to the negative first power. You don't want to do quotient rule with that, that sucks, because it's just a constant on top. So just change it to that. Now do power rule there, so that'd be negative 1 x to the negative second power. And then derivative of sine is cosine. The 5 stays out front. So there's your answer. Or you could write it negative 1 over x squared, because that's negative second power. Just move it to the bottom. It's probably a better way of writing it right there. Number 8. Okay, that one you do have to do quotient rule because there's an x on top and an x on bottom. So we'll do bottom times the derivative of the top. Derivative of x is just 1 minus the top times the derivative of the bottom. Derivative of 1 is nothing, so derivative of cosine is just negative sine. All over the bottom squared. And then just simplify the top. So that's just 1 plus cosine of x. And then this is x times sine of x. Negative times a negative is positive, and then it'll be x sine of x. Because you're multiplying by x, so that goes in front. And then on bottom you got 1 plus cos of x squared. And that's it. That's all you can do. You can't cancel this, of course, because there's a plus sign there. If that wasn't there, you could cancel one of the 1 plus cosine of x's, but you can't there, so just leave it. And there's nothing, I told you one of the identities, the only one I want you to remember at this point is cosine squared plus sine squared. If that comes up in a problem, you just put 1, which I think it does come up in the next one. Number 10. you got that. Again, you're going to have to do quotient rule because there's an x on top and bottom. So bottom times the derivative of the top. Derivative of cosine is negative sine minus the top times the derivative of the bottom, which will just be cosine all over the bottom squared. And then multiply out the top. So you have negative sine, distributive property, right? Negative sine of x. Negative times the minus would be sine squared of x. And then this is going to be minus cosine squared of x all over 1 plus sine of x squared. This one's kind of tricky because you have negative sine squared and negative cosine squared. So what you're going to do is you're just going to factor in negative 1 out of the top. And that'll change all of these to positives. Well, now you have sine squared plus cosine squared, which is just 1. So you have 1 plus sine of x on top, or sine of x plus 1, doesn't matter. So you have a negative 1 out there. It's sine of x plus 1. And on bottom, 1 plus sine of x squared. Oh, hey. This is multiplication, so you got 1 on top, 2 on bottom, so you can get rid of one of those. And your final answer would be negative 1 over 1 plus the sine of x. Just simplifying stuff. I mean, the derivative part was easy, and then you just got to simplify. That's like the only new part that we never really did. Sine squared plus cosine squared is 1. I explained why in the last video. 14. Let's see. 1 minus 4. Yeah, that says first thing is find velocity, speed, and acceleration at t. At time t. So there's position, velocity is just the derivative of that. Derivative of 1 is nothing. So you're going to have, remember, derivative of cosine is negative sine. So this would turn in, that's a negative 4, so it's going to become positive. Right? Because the derivative of that would be negative sine, you'd have a negative negative again. So it's position, velocity, acceleration, just the derivative of that, which would be 4 times the cosine of t. Oh, I thought I broke my pencil. And then the speed one, well, speed, you should know speed and velocity are related. Speed is just the absolute value of velocity because it doesn't matter what directions it's going. So when it wants the equation for speed, I guess you can't use S. I don't know what you'd use. Speed. It would just be the absolute value of 4 sine t. Just same thing as that one, just absolute value of it. B says find all of that stuff when t is pi over 4. So all you had to do is plug in pi over 4 for t. So you do s of pi, pi over 4. We're going to do all of them, just plugging in pi over 4. And if we do that, first one will be 1 minus 4 times the cosine of pi over 4. Oh, it doesn't say find position, does it? Okay, don't have to do that one. So velocity is 4 times sine pi over 4. And acceleration is 4 times the cosine of pi. Is this a no calculator? It is, technically. So you weren't supposed to use your calculator. Which means you would have had to have the unit circle memorized, but I know none of you do. Because sine of pi over 4 is root 2 over 2. So you'd have 4 times root 2 over 2, which is 2 times the square root of 2. But if you use your calculator, I think that's like 2.82 or something. 2. Yeah, 2.83, I guess. And if you do that one, you'll get the exact same thing. And speed, you'll get the exact same thing as that because it's positive. Describe the motion Okay. That's part C. This was B. Describe the motion of the body. Well, let's just figure out where it starts. So when time is 0, where does this thing start? So the position, 1 minus 4 times the cosine of 0. That would be what? Cosine of 0 is 1. So that would be -3. So you could say it starts at position of -3. And then which way is it going to move? You know what, let's just skip this. It's not on your test. This will be too long of a video. I mean, it's not like that on your test with the trig function. We'll save that for April. So what was next after 14? The next assignment was 18. Give you a function that says find the jerk at time t. Well, that's just the fourth derivative. So this is the derivative of the acceleration. So you got, there's your position, your velocity would be the derivative of that. Derivative of cosine is negative sine, so I'd have -2 sine of t. Acceleration, derivative of sine is just cosine. And then jerk, I guess we can call it j. Or a better way of writing it would have just been s prime, s double prime, s triple prime. Or you can put j of t, I don't know. Whatever, it's just notation. Anyway, it's just the derivative of that. So derivative of cosine is negative sine, so that's going to change it back to +2 sine of t. (22) Tangent and normal to y equals secant of x at pi/4. So remember, when you have tangent and a normal problem, just find your derivative so that you can get the slope at that point, and then write the equation of the line with that slope that goes through that point. So we need the derivative of secant. Oh, I guess I lied. I forgot when I said that the most important thing was the derivative of sine and cosine. That is the most important, but there's also derivative of secant, cosecant, cotangent. I guess I'll make you a deal. It won't be on this test. Just no sine and cosine. But they will be in the future. So derivative of secant will be secant of x, tangent of x. So if you want your slope, plug in pi/4. So I got secant of pi/4 times the tangent pi/4. And then you just got to plug that into your calculator. There is no secant button. So you have to remember secant is actually 1 over the cosine. Pi/4 times tangent, which it does have that button, so you're good to go there. So you multiply, or just do tangent pi/4 divided by cosine pi/4. You should get square root of 2, or 1.41. So that's your slope. So then you just got to figure out the point it goes through. Well, that's your x coordinate. So just plug that in, the secant of pi/4, which is, what is that? The 1 over the cosine. Of pi/4, which I guess you can use your calculator. Cosine of pi/4 is √2/2. If you did 1 over that, that'd be 2 over √2. It'd be √2/2 again. So I think it's 0.7 something. Let me see. 1. Let me see it. Oh no, it's 1. That is 1.41. What? I had to think for a second. I was just checking my answer for that one. I felt it was wrong. So there's your point. So then just point slope form, y minus 1.41. That's actually the square root of 2. Equals slope times x minus pi over 4. That'd be a good answer right there. That's your tangent. And then your normal would be just the same thing. But you gotta flip the slope and change the sign. So 1 over 1.41 is 0.709, so negative 0.709 times x minus pi over 4. That's not farting in the background. It's funny. They're girls, I can tell them. And my wife is pumping. So there's that. They're mostly girls. There's a couple guys. Let's see, what else? That was 22, 28. What is this all about? Oh, explain or show that the graphs have no horizontal tangents. And notice you can't use a graphing calculator. So how can you show that those don't have horizontal tangents without using a graphing calculator? Well, you have to think about what a horizontal tangent means. Horizontal this way, tangent. That just means tangent is the line that touches the curve, right? These are going to be curves. Horizontal tangent means that the slope at that point will be 0, which also means the derivative at that point, if you plug in x, you'll get 0 for your answer. So it's just thinking about slopes and derivatives. So slope. So you just do the derivative of each one. So the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. Remember, secant means 1 over the cosine. So if 1 over cos squared of x, that's the same thing as that. Derivative of cosecant, or derivative, we already did the derivative. Cosecant is the same as 1 over the sine. That one's negative. So a horizontal tangent occurs when the derivative equals 0, right? So what could you plug in for x to make that equal 0? And the answer is nothing. That can never be 0. Because no matter what you plug in, you're going to have 1 divided by something, can't divide by 0. Same thing here. 1 divided by something, can't divide by 0. So the derivatives of those can never equal 0. So you would just say, hey, those can't be 0. Right? Remember, it asked why there's no horizontal tangents, and it's because the horizontal tangent occurs when the slope is 0. Well, on these, we found the equation for our derivative, which is the equation for all the slopes, and we figured out, hey, that can't be 0 and that can't be 0, so there can't be a horizontal tangent. If you got that, you're awesome. And what's 34 about? Oh, more velocity, speed, acceleration. Ooh, and jerk. Let's see, so it gives you a function. At pi over 4. Pi over 4 again, that sucks. Because it's all root 2 over 2 stuff. So there's your position. Velocity will be just derivative of that. Derivative of sine is cosine. Derivative of cosine is negative sine. Acceleration. Derivative of cosine is negative sine. Derivative of sine is cosine. And then the jerk would be the third derivative. The derivative of sine is cosine. Derivative of cosine is negative sine, so that's going to become positive. There we go. So there's all of the equations. Now find them all at pi over 4. So we just plug in pi over 4 for t on all of them. And it's a lot of this calculator. You're not supposed to use your calculator. you guys probably can't do that. Anyway, if you plug in pi over 4 for that one, you get, or let's probably start with position. I already have the answers here. Just plug in pi over 4 for t. You should get square root of 2. This one you should get 0. This one, so that's position, velocity. Acceleration, plug it in for that one, you'll get negative square root of 2. And the jerk would be 0. So that's all of 3.5 homework. Like I said, I'll keep the crazy stuff on that section to a minimum on your test. I keep talking about this test, which will probably be Wednesday, by the way. Your quiz, answers for that. I'm just going to show you the answers so I don't have to sit here and work them all out. First one gave you a function. Initial position should have been easy. Just plug in 0 for t, because that is your position, right? So 0 plus 0 plus 2, 2 meters. And a lot of you need to start putting units on your things. If you're talking about position, it's meters, velocity is meters per second. Don't just say 2, because it tells you s is in meters, t is in seconds. So start doing that as of now. Initial velocity, so you find the derivative of that, which would just be negative 2t plus 1. There it is. Oh, at any time t. Oops. So I was going to say plug in 0, but it's at any time t, so you just leave it at negative 2t plus 1. There it is. When is the particle moving to the right? I don't think anyone got that one right. Move to the right when its velocity is positive. So the easiest way to do that is set the velocity equation greater than 0. You could set it equal to 0 to figure out when it stopped, and then plug in numbers on either side of that to figure out when it's moving, if it's positive or negative. But greater than 0, velocity greater than 0 is moving to the right, so you solve that. Subtract 1, divide by negative 2, flip the sign. So it'd be less than, t is less than a half. So anything from 0 to a half is when it's moving to the right. And I knew someone will ask, probably just would have got that, t is less than a half, but I put that there because remember it says for any time t greater than or equal to 0. Some people had negative answers for t. Well, those aren't in the domain of our problem, because it tells you right at the beginning t has to be greater than 0 or equal to 0. Acceleration, just do the derivative of that, which is negative 2. Boom, done. There's no t in it. So, oh, and it says at any time t. Bonus, find the speed. At the moment, the position is 0. So you have to figure out when is the position 0, and then plug those in for the velocity equation. So set the position equal to 0, so factor it, solve it. You get t equal to 2 and t equals negative 1, but we don't care about negative 1 because it tells us that time has to be positive. So we got a positive 2 for t. Plug that in to your velocity equation, and you get negative 3 for your velocity, which means the speed is 3, because speed is the absolute value of velocity. Next one. Oh, and here's the scoring too. If you're playing along at home, you get 1 point for A, 1 point for B, 2 points in C. If you get part of C, you might get 1. I don't know. D is 1, and then E is bonus. Depending on how you did there, you probably get up to 2 points of bonus. So you should score yourself, and then you could check later and see what I gave you and see if we agree. Vertical motion. Okay, so here's a position function again. First problem, find the first two derivatives. So there's your first derivative, 64 minus 32t. Second derivative, just negative 32t, 1 point each. How long does it take to reach maximum height? Well, maximum height is at the vertex of, so the velocity is going to be 0. So we just take our velocity equation, set it equal to 0, and you should get 2 seconds. 1 point for setting velocity equal to 0, 1 point for getting the right answer. Pretty simple. Now, with what velocity does it leave your hand? Well, that's just the velocity when time is 0, like right when it leaves your hand, Plug in 0 for your velocity and you get 64 feet per second. Start putting those, or it'll be wrong. But right now it's fine if you just put 64 because I didn't tell you. So that's 5, or 1 point there. Bottom, just had to figure out, like I said, which one's the derivative of which. Easiest to figure out where the slope is 0. In this case, the slope is, if I start here, the slope is 0 at 1, but none of, oh, that one hits that one at 1. And the slope is 0 here, here, and here. So this one, the derivative of this one, should hit 0 at 0, 1, and 2. Well, here we go, 0, 1, and 2. I guess it's kind of off. That's kind of stupid. Well, it doesn't go to exactly 0. You can't tell it's exactly flat, but it's really dang close. So this one hits 0 at half and at 1.5. Well, none of them hit that, so that must be acceleration. Here we got zeros at 0 and at 2, so 0 and 2. So hey, that's the derivative of that, that's the derivative of that. So you got position, velocity, and acceleration. A point each. So there's that. With the rest of your 20 minutes here, here's what you're going to do. I gave you all that big of a review assignment last time we talked. You have all of the, even though those are, I think I gave you even problems, I don't remember, but you have all the answers for them. They're in the back of the book. So you can look them all up and figure them all out and figure out why you got it wrong if you did. You have all the answers. So I'm just going to give you, alright, I gave you the, can't remember if I gave you that one or that one. Either way, whichever one I gave you, you have all the answers. So don't do the other one. What you're going to do now, in addition to that, is more test-like review. These are great test-like problems, which give you them today, and then tomorrow I'll Skype you guys and have it. You can ask any questions. I will expect all of this to be done, and then your test will be Wednesday. It'll be fun. So there's like one from each section here. 3.1, number 26. 3.2, number 30. 3.3, number 46. 3.4, number 19. 3.5. Where'd it go? Number 10. And then on page 148, there's the review problems. Do numbers 26 and 45, and then also numbers 39 and 42. These say no calculator, but I say use your calculator. I think. And then one more. Can't remember if I needed to give you more directions. 39. Oh no, that's fine. Use your calculator. Remember, that's the whole end deriv thing. Oh wait, no, 39 and 42. Hold on. I dropped some papers. I can't find what I had. Oh yeah, that's right. I didn't want you to follow on these, don't follow the directions. It says find the second derivative of each one. Okay, maybe for that one. No, okay, here. Dang it, I wrote this down last night, now I can't remember what I was thinking. Nope, here's what I want you to do. Do these with the calculator, don't follow the directions. Find the derivative at, we'll say pi over 2. So remember, you can do the whole end deriv, y1, with respect to x, comma, pi over 2. Yeah, do that for those two. And then one more, just random. Just do the derivative of this. So there's the whole thing. Pause it if you need to. I will talk to you tomorrow.